This is a major report on soils of the Illawarra for EESC202 by Georgia Mood. This report focuses on the formation and application of soils in the Illawarra. The Illawarra region is renowned for its lush rainforest-dominated scenery capped by large sandstone cliffs. These cliffs are eroded and undercut due to orographic precipitation over the escarpment. The diverse parent material of these cliffs, over time, has created an array of soil types and interactions, and this is a result of the 5 factors of soil formation: organisms, relief, slope, parent material, and time. The aim of this report is to understand how different soils are formed and explore the effect of soil quality on land use. It is vital that soil formation of the Illawarra is investigated further to find other applications for soil use in this area, as well as developing new methods to deal with slope stability. Why are soils of the Illawarra region so varying? The theory behind this question is based on the 5 factors of soil formation: organisms, relief, slope, parent material, and time, all unique for the area. Soil complexity can be attributed to the great heterogeneity of parent material that these soils have developed from. Soil change in a systematic cantonia in accordance with the steepness of slope and drainage capacity, as shown in this diagram, where the sequence of soils down a slope are being created by the balance of processes such as precipitation, infiltration, and runoff. In the Illawarra region, climatic changes affect the degree of weathering as well as local differentiation in parent material composition. Soils in the Illawarra region develop from a top to bottom weathering profile. From the escarpment, there is a downward migration of weathering front, which is the boundary between parent material and the weathering profile. This profile will thicken with time as sediment is deposited. In this image and footage, you can see some of the various parent materials from Bald Lookout at Stanwell Park. Zooming in, you can see the saddleback in the distance on the wide coastal plain, followed by the tertiary basalt, Hawkesbury sandstone stretching all the way down the southern coast, Narrabeen group, moving down to the Bulleye Coal Seam and Coal Cliff. Soil profiles of the Illawarra develop over a long period of time through the same complex processes. Soil forming factors interact to form the soil profile: climate, topography, parent rock material, and vegetation cover, as seen on these boulders in Stanwell Park. Soil profiles may be formed by weathering or deposition processes such as this tessellated rock platform at Wombara, the spheroidal weathering largely occurring at the northern cliff of Stanwell Park, as seen here, or hydraulic wave erosion at the southern cliff of Stanwell Park, seen here. Parent material sitting on top of bedrock may be weathered to form part of the soil profile. Addition of organic matter on the surface or deposits carried by wind or rain form duplex soil types. Horizons are then created through various physical and chemical processes depending on the area. For example, this soil profile at Wadi Wadi Track has a large A horizon and C horizon. The transition between rock and soil is very sharp, indicating a colluvium deposit. Soil biota break down organic matter and form pores and clusters in the soil. In this section of the report, I will explain the types of soils found in different areas of the Illawarra and some of their applications, the first of these being the sandstone plateaus. 2 distinct plateaus being the Hawkesbury sandstone stretching from Sydney to Cabrawara Range and the Nowra sandstone over the Shoalhaven district. From these, various soils develop: skeletal soils found all over the plateaus, small rock fragments, and the sand. Yellow earths develop from sandstone with higher clay content, and acid peat soils are formed from reducing conditions due to a high water table. Podzols have a defined A and B horizon and are found on well-drained deep sands. Finally, ferrocrete, formed from sandstone which has been chemically and structurally changed and where iron is plentiful. The sandstones and coastal sands lacked nutrients, making them expensive to fertilise, so were avoided for agricultural or pastoral uses. Some exceptions include orcharding west of Stanwell Park, such as at Glen Burnie Orchard near Helensburgh, and farmlands on the coastal lowland, such as Clover Hill Dairies, situated on the alluvial floodplain adjacent to the Jamboree Township. Soils on talus of the escarpment and gorges. Downhill movement of precipitation and debris is the main factor of soil formation in this area. Skeletal soils and podzolic soils, in particular red podzolic, are commonly found. At the base of the escarpment, aged talus shows signs of intense weathering, and there is mottling of iron and clay around boulders. Some farming is done in these soils, but due to their sandy nature means there is a lack of nutrients available for plants and fertilizing is extremely costly. Red, yellow and grey podzolic soils on shales and siltstones. Berry and the Illawarra coal measures, seen here at Woombarra, are rich in clay in the B horizon. The podzolic soil profiles are widespread, but little is known about how they develop. Coal mining of these measures was once a major commercial enterprise in the Illawarra. Volcanic chasmosomic soils. Found around Robertson and Kiama, they are clay-rich and moving down the soil profile contain rock shards. Red chasmosomes are distributed around Kiama and Gerringong and also contain a high clay content. These soils have been farmed in the past and are highly favoured, but increasing urbanisation around Kiama and Gerringong means a lot of the farmland has been lost. Soils on alluvium. Weathering has played a major role in soil development. In the past, sediments have been deposited by rivers, but no new sediments have been deposited as streams have dropped below their past floodplain level. Red and yellow podzolic soils are the result of long-term weathering. These areas have also been used for farming applications, such as this winery in Gerringong, sourced from Hawkesbury Harvest 2001, image by Australia Webb. Coastal sediment soils. There is little evidence of soil development in coastal areas of the Illawarra, as the sediments are mainly dune and beach sands. Humus podzols can be found around Kemble formed through long-term weathering. Acid sulfate soils around the Shoalhaven River developed from reduction in waterlogged estuarine sediments and then oxidized again, creating sulfides which release sulfuric acid. This causes soils to drop to a low pH of around 2 to 4. These soils are extremely acidic, which makes it extremely hard for flora and fauna to thrive, and any agricultural applications are non-existent. This image of scientists monitoring fish populations in an area of the Shoalhaven River is subject to acid sulfate soil drainage and was sourced from New South Wales Department of Primary Industry. Slope stability is the most profound problem in the Illawarra region. Landslides are a risk due to undercutting and erosion of the sandstone of the escarpment. Risk assessment and planning for urban developments or roads is important for all areas along the escarpment. My case study was the use of soil mapping in the Illawarra. Soil maps have been developed using GIS and other modern digital mapping technologies. The mapping of these soils is a result of a soil survey where different types of soil of the Illawarra are put into a database. This image shows the layering of data used in GIS and was sourced from srh.gov 2014. From this, a geographical representation showing the soil types and soil properties of the area can be produced. Modern applications include risk assessment of landslide risk along the escarpment, spatial planning, agricultural extension, and environmental protection. These modern mapping techniques produce maps that are richer in context and show higher spatial detail than traditional soil maps. In 1996, the former Hawkesbury Nepean Catchment Management Trust asked DLWC to provide information on the capability of the area for septic trench on-site effluent disposal, as there were concerns that trench disposal systems were adding pollutants to the Hawkesbury Nepean River system. the department produced a series of 1 to 100,000 degree of limitations for septic tank trench disposal maps using available soil landscape information. This included the Wollongong Port Hacking Hazelton and Tilly 1990 1 to 1000 map sheets. The maps showed the lower catchment had moderate to severe constraints present. These maps allowed measures to be taken to develop appropriate solutions to the problem. To conclude, soils are not only important for the Illawarra region, but all over the world. By gaining a deeper understanding of how soil properties relate to and can be managed for optimal agricultural practices, forest, range and wetland management, urban land use, waste management, and also the rejuvenation of disturbed sites such as mines. After mining finishes, the mine area must undergo rehabilitation to ensure there is long-term sustainable vegetation on old mine sites. To help remediate the adverse physical and chemical properties of the sites, a choice of appropriate vegetation will be most important. I believe there is a lot more work, research and development to be done in this area of soil sciences. For my self-assessed mark, I believe I should get a 4 for the content and development. For organisation and structure, I believe I should also receive a 4. For mechanical conventions, a 3. For critical thinking, also a 3. And for presentation, a 4. My reasons for these marks being I believe I have a deeper understanding of the topic of soils in the Illawarra region. I have conducted extensive fieldwork and independent research all over the coastline and escarpments of Illawarra. I have summarised my information well, and I believe I have communicated my main points clearly to the audience. The process of making a film is extremely time-consuming with lots of technical difficulties, which I believe deserves extra credit. Planning the script of this film was another difficult and challenging side to this project, which required a lot of critical thinking and pre-planning before the actual filming could commence. Thank you for watching. This has been a major report on soils of the Illawarra for EESC202 by Georgia Mood, University of Wollongong, 2014.